Okay, this is the first PowerPoint for Chapter 2. This is Lesson 2.1 on rational numbers. So during class, we made two foldables. We made the real number foldable, which helps us categorize numbers. And then we also did the two vocabulary entries, which were terminating decimals and repeating decimals. So one of the first things we talked about today was changing rational numbers, which are numbers that can be written as a ratio of two numbers or as a fraction, into decimals. So when we have a whole number like this first example here, that -7 will stay -7. That's not going to change. Now what we do for our fraction is we're going to divide numerator by denominator. So 3 divided by 8 is what this 3/8 means. So our 8 is going to be our divisor. Our 3 will be the dividend. So when we line that up, we see how many times 8 can go into 3. Since 8 cannot go into 3, we're going to put a 0 there. We're going to add a decimal. Put a decimal right behind the 3. I'm going to add a couple zeros here. So 8 goes into 30. How many times? Here, 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. So we're going to put 3 there. Bring down 24. We'll have 6 left over. Bring down a 0. 8 goes into 67 times. 7 times 8 is 56. So we'll have a 4 left over, and then we bring down our last 0. And 8 goes into 45 times. So there will be no remainder there, and that's what we're going for. We're going to move on until we get a remainder or a repeating decimal. So we have -7, and we're going to take this this decimal here and add it to my whole number. So changing -7 and 3/8 into a decimal would be -7 and 375 thousandths. Now we're going to go to the second example. We didn't do this one in class. We have -3/11ths. So this, since there is no whole number, our answer is going to be less than 1. And it's going to be negative. So I'm going to have -0 point something. Now again, this is 3 divided by 11. So 11 is my divisor, 3 is my dividend. I'm going to add a 0 and a decimal, add a couple decimals here. 11 goes into 32 times, which is 22. We have 8 as a remainder. Bring down the 0. 7 times 11 goes into 80, which is 77. 3 left over. I'm going to put another 0 down there. 11 goes into 32 times, which would be 22. And we are going to start seeing a pattern here. Bringing down another 0. So our remainders start at 8. We have a remainder of 2, a remainder of 8. I'm sorry, a remainder of 3, remainder of 8. So we're going to start seeing 11 goes into 87 times. So we're going to have a repeating decimal. And what repeats is the 2 and the 7. So we're going to write 27 with the repeating bar. That's our bar notation, saying that 2 and 7 in that order repeat forever and ever. So it's -0.27 repeating is how we could say that. Moving on to our second type of problems, it'll be taking our decimals and writing them into rational numbers, meaning writing them as fractions. So the way I like to think about this is the way you read it is the way you write it. So this is -7/10. Once I get into fraction form, I need to look to make sure there's anything I can do to simplify. Here, there isn't anything, so I go ahead and move on to my second example, which is -10 and 25 hundredths. So I'm going to write -10 and 25 hundredths. So for this case here, we need to make sure we know our place values with decimals. So if we need to review that really quickly, that'd be a good idea. But if we look at this fraction here, we can divide numerator and denominator by 25. So my new mixed number would be -10 and 1/4. Okay, and last but not least, we have comparing rational numbers. Now, I talked about comparing rational numbers and using that to order our rational numbers. And we're going to see that both of these, they're in two different forms. One's in a mixed number, one's in decimal form. So I want to change them both into the same form so I can compare those two. And then also they're both negative, so we have to be careful when we're comparing our negative numbers. So first what I'm going to do is take this mixed number here and I'm going to change it into a fraction. Negative 4 and 6/10 would be negative 4.6. If I didn't know 6/10 could be right as 0.6, I could do my division problem off to the side, my long division. And 10 goes into 66 times with no remainder. So it would be 0.6. So negative 4.6 and negative 4.65, that has stayed the same. Now if I'm thinking about decimals, or any numbers in that case that are negatives, it's the number that is closest to 0 is the largest number. So I have a tenths place here, and I have hundredths place. I'm just going to add a 0 so I can see that. So negative 4 and 60 hundredths, or negative 4 and 65 hundredths. Since these are negative, so then I want to think about if I'm going to plot these points on a number line, which number is going to be greater by being able to tell which one's closer to 0. So if I were to plot these two on a number line, negative 4 and 6/10 would be greater than negative 4.65, because 60 hundredths and 65 hundredths, since this whole number here is less than this whole number here, it's a greater number because we're looking at negatives. If I had 4.60 a positive and 4.65, I could look at this like money, and 4.65 would be bigger. But here we want negative 4 and 6/10 is greater than negative 4.65. So hopefully these examples helped you with your homework. There are some problems talking about ordering numbers least to greatest. The biggest hint there would be to change them all into the same form. So I would go all decimals, and then putting them from least to greatest, being very careful with our negative numbers.